Good morning, everyone. So we're going to take a look at 12 different igneous rock samples today, which is lab 33 in your progression of labs so far this year in earth science. It may differ from year to year. So if we're not operating in the 2020-21 school year, the sequence of labs is not as important as the content of the lab. And I may use this video content for multiple years. So, but for our purposes this year, this is lab number 33, igneous rock identification. So let's take a look at the first sample that we have here in the box. So you can clearly see that there is no crystalline structure here. And again, I'm looking at page 7 in my reference table, my scheme for igneous rock identification. And I'm working from the left side of the chart over to the right. And I can see that the first thing I need to find is my environment formation. Then I'm just going to look at the overall characteristics of the rock. So I see right here with this sample, very glassy texture. It's beautiful. It's actually quite beautiful. It's one of the most beloved of all igneous rocks. Igneous rocks can be beloved. And I see a type of fracture here called conchoidal fracture, where you see those half circles, those little half moon shapes. Looks very similar to how glass breaks, because the composition of this rock is very much like glass. Okay, so I see here that this is glassy. I don't see any crystals. And so instantly, I'm going to go back to my table and see here that I've got glassy listed as a texture. I'm going to follow that over, and I get into this space here where I've got multiple options. Now I see that vesicular gas pockets tracks the bottom part of my 4 options. And so I'm going to rule out pumice and scoria because I don't see any vesicles in this rock. It looks literally like a solid piece of glass without any gas bubbles, which is what the vesicular texture is composed of. And so I've got 2 choices. I've got basaltic glass or obsidian. And to be honest, it's very difficult to sometimes determine the difference between the 2. And so this piece right here, it's very thick. And you can see that right there. It's almost got some reddish streaks in it if I zoom in a little bit closer. I'm sure you can make that out. Those reddish streaks. And if I was to find this sample or smaller pieces of the sample, it would actually be quite clear. And so, although it says obsidian usually appears black, I'm going to zoom out a little bit so you can get a better read on the text. This is obsidian. It usually does appear black, okay? But it's listed as what's called a lighter color felsic igneous rock down here. It falls here, and it's only darker in color because it's so thick. And if I was to again chunk it up into thinner sheets, it would allow the light to flow through it quite readily, almost like a tinted window on a car. So I'm going to choose obsidian as my choice here. And then all of the rest of the characteristics. I know obsidian is an extrusive texture, meaning it was spewed out of a volcano and it cooled down very quickly. That's where glassy texture comes from, extreme and rapid cooling. And I know that all the other characteristics, including the mineral content talked about down here, all of these minerals exist within this piece of obsidian. So it's lighter in color, it's lower in density, it's felsic. All of these different minerals, again, use your reference tables to figure that out, are held within this rock. So that's obsidian. Our second sample is quite different. Some portions of it are glassy, but it's nowhere near as glassy as our obsidian. But I'm not going to rule out glassy texture from here because there are some spots where it does kind of tinkle and shine up at me. Interesting. I notice it's very light. And if I look very closely at this sample, I notice also that it's got very tiny gas pockets held within it, very tiny. So if I look back at my identification chart again, I can see that vesicular texture is up here. And if I'm looking down, I've got some glassy texture. And I've got two choices. Actually, I've got four. It could be vesicular basalt, andesite, rhyolite, pumice, or scoria. And if we're talking darker colors, these are your choices: scoria, vesicular basalt, or vesicular andesite. We're not going to see these samples pop up today. So I'm just going to help you out, and we're going to rule those two out. But you will see scoria and you will see pumice. The primary difference between scoria and pumice is that scoria is darker. Pumice is typically much lighter in color. Okay? So that's where they differ. Now, this sample I would classify as pretty light in color. So that's why I would call this sample pumice. Commonly used, and again, also an extrusive igneous rock spewed out of a volcano, cooled down real quick. That's how the gas pockets developed in it. And then you've got lighter color, got lower density, it's felsic, and then all these minerals are within the sample. Sample number 2, pumice. Now, back to back. Sample number 3, also gas pockets, prominent gas pockets in this one. It's a lot darker and maybe some loose or almost glassy texture right through here. I am going to go right back to the same spot on the chart that I just was. Be very suspicious of this rock being scoria. We'll look it over a little bit more, make sure everything fits. Definitely gas pockets. I don't see any crystals here, so it's non-crystalline. And it's darker in color. Yes, I'm going to choose this one as scoria. Okay, darker in color, higher in density. It's mafic, meaning it's rich in iron and magnesium. And then all of these minerals that are underneath it, following the chart down, would be present in scoria. Okay. My next one, looking at here, I notice instantly that it's heavier. I also notice that there's some small crystal faces that shine up at me when I move the rock back and forth, reflecting that light from within the room back into my eyes. So darker. I don't see any gas pockets in this one either. It's a very solid rock, very dense. So I'm going to look here, and I see that the crystals are present, but they're very fine. Okay, again, texture. Igneous rock texture is defined as glassy, fine, coarse, or very coarse. And it's all about the progression of the size of crystals. The absence of crystals, tiny crystals, fairly big crystals, 1 to 10 millimeters in diameter, which are quite big. And then very coarse crystals, which are 10 millimeters or larger. Right here, I would say that this rock has some crystals in it, but they're fairly fine. So I'm going to go here. And it's dark in color, so I'm going to rule out rhyolite. And it's not really even in the middle. It's actually quite dark. So I'm looking at basalt. Good about it? I do. It actually has a slightly greenish hue, which denotes that it could have some olivine in it as well. And if I look down, I see pyroxene and olivine as two greenish minerals that are found within most samples of basalt. And so that's how I'm going to identify our fourth sample here as basalt. Okay. Darker in color, higher in density, mafic in its origins, and these are the minerals found within. All right, my fifth sample here, my igneous rocks, is much lighter. It's got, let me zoom in a little bit. It's got a very, if I turn off my light, maybe you can see a more accurate set of colors. I'll turn it back on. Okay, so it's lighter in color. And if I move it back and forth here a little bit, I can see that it's got some crystal faces shining up at it. Some. They do not make up the majority of the matrix of this rock. And what is matrix? Matrix is simply what makes up the overall composition of the rock. So the matrix is all of the pieces holding the rock together, working together as a singular unit. So the matrix of the rock, meaning the rock itself and all the parts that hold the rock together, is not predominantly crystalline. So I'm still going to classify this texture as fine. It's got fine texture. And most our fine textured rocks are still going to be classified as extrusive or volcanic, meaning they formed on the outside of Earth. Okay, so the sample right here, it's got some crystals in it. It's lighter in color. It's fine in texture. I have a suspicion that this rock may be a rhyolite. Rhyolite, if it fits, will fit all the other markers here. So I'm going to look over. Yeah, if it has any crystals, they definitely are less than 1 millimeter, except for some of the little porphyries inside of it, which are still very, very small. Fine texture, lighter in color. Yes, I feel good about calling this rhyolite. So I know that it's lighter in color, it's lower in density, it's felsic, and then all of these minerals will be found within it in various levels of concentration. Now here's my next sample. I'm just going to give this one to you. It's not on your reference table, at least as a singular rock, but it is another type of rhyolite. You can see the porphyries shining up at you. The little tiny phenocrysts, if you will, the little tiny crystals that are embedded within this rhyolite. It started to grow some crystals. It was not right on top of the Earth. As it cooled, it started to grow some crystals, but it cooled down quick enough where the crystals didn't really become the overwhelming majority of what makes up the matrix of this rock. So you would still call this texture fine because less than 50% again of the matrix of the rock, or the overall composition of the rock holding it all together, is not crystalline. It's fine, or it's got fine texture. Or the overall texture or matrix of the rock is not coarse in texture, but it's fine. So this is also called rhyolite. Now it's got a specific name. This is called a rhyolite porphyry because you can see those small crystals of quartz inside of it. Our next sample here is one of my favorites because it's so distinguishable. It's very easy to make out what this is. I'm going to turn off the light so you can see the different feldspars inside of it. You've got a mixture of some orthoclase feldspar, which if you remember from the mineral lab, is this stuff right here. And then you've got a mixture of that grayish or sodium and calcium rich feldspar called plagioclase. And those two minerals are abundantly found in the sample. You can see that this is our first really coarse textured igneous rock. You could even call it very coarse because the crystals are so large and they're interlocking, meaning they work together singularly to make up a rock that really feels quite uniform. If I was not looking at this rock but just feeling it, I would not be able to feel necessarily the different crystals. It would feel like a singular rock. But as I look at it, I see many crystals that are locked together, working together to make up the overall texture of the rock. So what is it? Let's go to our chart. So I see right here, I'm really thinking it's granite. I'm going to check. Okay, intrusive or plutonic, meaning the rock formed underground. Makes sense because we can see big crystals. Very coarse crystals, coarse to very coarse, absolutely texture. No gas pockets. There's no vesicles here. And it's a little bit lighter in color. I see some darker minerals here, but they don't make up the majority of the matrix of the rock again, like I've stated before. So I would still call this a lighter colored rock, and therefore I'm going to go with granite. lighter in color, lower in density, intrusive as far as its environment of formation. And then again, all the minerals found in the granite are right there. So that's our sample number 7. Number 8, it's right here. I'm going to give you this one as well because this is not found in the reference table. This is called a pegmatite. This is a very coarse textured igneous rock that's made up of predominantly one type of mineral, and it's usually a combination of quartz and feldspar within pegmatites. Very intrusive, very intrusive. Okay, and if it is on our reference tables, I forgot. I misspoke. Okay, so you see pegmatite down here, very coarse, 10 millimeters or larger, and you can see those crystals really kind of stretch across the whole duration of the rock, almost in layers. Very coarse texture, 10 millimeters or larger. Now, because it's so light, I'm going to slide it over here and then identify it as lower in density felsic with all these, mostly the lighter colored minerals that could be in the rock existing here. So lots of potassium feldspar and lots of quartz. Okay. I know that because of the slightly tan or pinkish hue and the clear quartz crystals that run across to complement those feldspars. Okay, so that's my sample number 9. That's actually my sample number 8. Sample number 9 here is this one. Now, this is an interesting one. It's very similar to granite, but it's not quite granite. I'm going to give you this one too. This one is called syenite. It's spelled S-Y-E-N-I-T-E. And the rock looks a lot like granite, but it doesn't have any quartz in it. It's predominantly biotite, you've got your amphiboles, you've got some pyroxene, and you've got an abundant amount of plagioclase feldspar here. Okay, so this one would kind of fall in the middle of the chart if it were on the chart. And the reason I'm giving it to you is because it's not on the chart. So syenite would kind of be somewhere in this space. So you could classify its color as kind of a medium or gray. You could say its density would be medium. You could also say that its composition is a combination of felsic and mafic. You could check both if you'd like. And then you can see right here in the middle of the chart, you got a lot of plagioclase feldspar, white to gray. That's why I would call this this piece of syenite very much in the middle, almost like diorite, but not quite, or andesite. No vesicles, no glassy texture. Again, lots of interlocking crystals that are big. And so I would make sure to indicate the texture is coarse, okay, and nothing but. So that's sample number 9. Here's number 10, my salt and pepper rock, as I like to call it, or it's commonly referred to as trap rock. Now, this is a great example of a coarse textured igneous rock. Again, you see those crystals shining up at you, especially as I tilt it back and forth. If I turn my light on here, you should be able to see those crystal faces shining up at you. Okay. Pretty rock. I like this. Very good mixture of both light and dark colors. So it falls right in the middle of the chart. It's not glassy because they're all crystals working together, intergrown together, so not glassy. And again, what's the difference between glassy? Well, this is a glassy texture again. You don't see any crystals here, but it looks like a piece of glass. Right here, it doesn't look like a piece of glass, but it does have little flat crystal faces shining up at you. So this one would, because of its coloration, well, because of its texture too, being very coarse, we're going to call this an intrusive igneous rock, right? Because we know that because it has interlocking large crystals in it or coarse texture, it must have formed under the ground or intrusively. So I'm going to look back to here and I see coarse as its texture, and I see light and dark colors all through here. So I'm going to fall into the middle of the chart and call this rock diorite. And look down, here's all my different mineral samples, and you can kind of be right in the middle. You can check both light and dark if you'd like. You can check both higher and lower density, and you could select its composition as both mafic and felsic in this rock, okay? So that's diorite, salt and pepper, or trap rock. Okay, this sample right here, It's a very good example of gabbro. Oh, I just gave it to you. Well, there you go. We'll work backwards on this rock because I just gave you the name. So again, coarse texture, absolutely. Very coarse texture, well, maybe in some spots. But I would list it right here as definitely coarse texture. I don't see any vesicles in the sample. Okay, it's all quite uniform in its coarseness. And I know that it falls on this side of the chart, being among my darker minerals, higher in density, quite mafic, okay, and intrusive as its environment of formation. That's my 11th sample. And my final sample here is a cool rock. I'm going to turn on my light here for this one. You can kind of see a little bit of a greenish hue back all the way through the rock, permeating through the rock, fairly green. So this rock is not on your chart, so I'm going to give this one to you as well. This one's called peridotite. Peridotite. So actually, it is on your chart. I misspoke once again, but it's very small. It's right down here as peridotite. So if you find it there, coarse texture, you see those crystals all throughout. Okay, no vesicles, so it's non-vesicular, and it's darker and heavy. So it's got a higher density. It's mafic in composition, and you see all of these minerals present, especially high in pyroxene and olivine. So that's sample number 12, peridotite.